Hello, Math Analysis. Happy Monday after prom. As you could tell, I'm still very sick. I am here, but I figured some of you might need to watch this video for Wednesday's quiz, so here goes. Start with a little trivia fact. This past winter, Boston had a huge snowstorm. In fact, it was a record-breaking snowstorm. Anybody have an idea how many inches? Oh, it's not in the PowerPoint. There we go. 108.6. Wow. Good luck to those of you going to the East Coast next year. Pack your boots. All right, so anyway, we are about to learn something today called spanning trees and minimum spanning trees. And part of why we would want to do something like this would be for a situation. So if you take a look at this, Chicagoland is expecting a huge snowstorm. We're talking like 3 feet of snow. So the 10 towns got together and said, you know what, here's our emergency plan. We're just going to pave a road between the various cities so that you can at least get to one city to another, so that we plow the least number of roads but keep a route open between each pair of towns. It does not have to be a direct route though. So I'm going to give you a chance to try it first and see how you do and if you can find a route. Note there'll be many answers, not just one unique. All right, put it on pause and see how you did. And here is one solution. If I was in Bolingbrook and I spanned out from Bolingbrook, I will show you a couple other things. So Bolingbrook was where I started, and then I went to all of the adjacent vertices, and I labeled those 1, Downer Grove, Naperville, Romeoville, Orland Park. Now I can leave from those cities. So also think about it like the game of telephone, where all the power lines are out and you're sending runners to the towns to leave a message. So if Bolingbrook is our central hub and you send everybody out, they could only go to Downers Grove, Naperville, Romeoville, and Orland Park first. Now they'll leave those 4 towns and go to the nearest town they can get to. Notice you'll have a different graph than your other partners. What we're looking for is how many rounds of communication does it take until all towns have received the message. If you look in this graph particularly, it takes 3. Here's another option. What if you started in Naperville? Now I didn't write the numbers below that, but we're getting to that. All right, so notice that your graph has some similarities to it. And one of the things is that the graph you're creating is a tree. So what are the 2 criteria of a graph to make it a tree? We learned this on Friday. Did you say connected graph with no cycles? Good job. All right, so this isn't just called a tree, this is called a spanning tree. And the definition of a spanning tree is a tree in an undirected graph, so it does not have arrows on the edges, that touches all of the vertices. So on this one screen, I wanted to show you all possible different routes. Now the green, pink, yellow, and blue all have something in common. Count how many roads each person chose to plow. And you'll notice that each graph plowed the same amount of roads. So our similarities were all graphs contain a tree, and all graphs be sure to make it to all of the cities. So if a graph has n vertices, the spanning tree will have n minus 1 edges. So in this problem, there was 10 towns, so we will have to plow 9 roads. All right, this is another example of a spanning tree. They're everywhere on the internet, computer science stuff. So we'll start off easy. All right, so see that graph there. And there is a handout, by the way, that you could use these documents if you go onto Weebly and print it. Okay, how many different spanning trees can you find in here? Put it on pause and try. Did you find all 4? Notice they're connected with no cycles. All right, if you didn't do so well on that one, we'll give you another chance. Make the diagram slightly more challenging. How many can you find? Put the computer on pause. And did you find 8? Good job. All right, last chance. How many can you find in this slightly complicated diagram? Did you say 16? All right, so that's just warming us up to learn how to do trees. Notice this guy right here, it's not a cycle. There's not a vertex there, so you could only go from here to there to there to there. That'd be a Hamiltonian path, actually. All right, can you find a spanning tree in this grid? There are many, but here is one. All right, so we're going to learn an algorithm. It's called the breadth first search algorithm. And the way you do it is what I explained earlier. I give you a starting town, and you label that 0, and you span out to all adjacent towns and label them 1, and span out to adjacent towns and label them 2, and continue on until you're done. All right, open your packet to page 17. You're going to try one. So your starting town is A. Put the computer on pause and see how many rounds of communications does it take until you get to all towns. Be sure when you reach a town, you put what communication round it's been to get there. All right, so if you take a look at this, we spanned out and it took 5 rounds of communication. All right, but what happens if our graph isn't just a graph, but it has numbers on it, or it's a weighted graph? Well, there's a different algorithm, and its name is Kruskal. So we're going to try one here. It's a greedy algorithm because the greedy choice is to pick the smallest weight edge that does not cause a cycle. So don't look at the numbers in the dots, just look at the numbers on the edges. Which one is the shortest edge? Hopefully you said 1. And keep track of your numbers. Okay, now you look for the next shortest roads to plow. And there's 2 of them, plow 2. So my goal is to try and create a spanning tree by reaching out to all the vertices and not creating any cycles. And we're up to length of 5. All right, now we see path of 4 to length of 13, path of 7, length of 20. Notice I did not choose the green 7 because it would have made a cycle. Right here, it would have cycled it off. Path of 8, and path of 9. And you're done when you've reached all vertices. It's called Kruskal's. Here's the rules. Start by selecting the smallest edge and darken it. Look for the next one and darken it. Continue till you've created a spanning tree. Notice you have to visit all vertices and you add up the edges. All right, turn to page 18 in your packet. Here's a practice one. And there's the answer. And one more for you to try. Put it on pause, see how you do. And you should have gotten 66. All right, math analysis. This is the end of chapter 5, quiz on Wednesday. Take care, be well, be healthy, finish strong.